Another one of our gas laws is Boyles Law. Now, Boyles Law, it's going to tell us the relationship that exists between pressure and volume. This is one of the first indirect relationships that we're going to see amongst these gas laws. What an indirect relationship is a relationship in which as one of the variables increases, the other decreases. So if we look here at these two graphs, you can see here, this one's got the numbers on it. Pressure starts up here at 120 and volume is at 10. We see how as volume increases to 50, the pressure decreases all the way here down near 20. So it's just like if you think about having a container with a gas in it, and as you compress that container, the volume's going to shrink and the pressure is going to increase. So the volume's decreasing, but the pressure is increasing. Then if you make that a larger volume again, you can picture in your mind the gas particles are going to start spreading apart once again, and then that's going to decrease the pressure as the volume increases. So we're looking at pressure and volume here. Volume, of course, measured in liters. Pressure is measured in a number of different ways. You remember it's millimeters mercury, kilopascals, or atmospheres. We always want to try to convert to atmospheres, and these are the two conversions you're going to need. 1 atmosphere equals 760 millimeters mercury, and 1 atmosphere equals 101.325 kilopascals. Always convert to atmospheres. It's going to be really helpful for consistency purposes. So you always want to try to convert to atmospheres. And this indirect relationship, that's one thing you want to remember. You want to remember these graphs for sure, and pressure and volume. So that is a basic intro to Boyles Law. And we're going to jump right into some practice problems that represent Boyles Law. But just keep the picture in your mind of like a container spread apart, low pressure, compressed. That pressure is going to increase. So we look here, I have our formula up here. It's the same process we've used for the other laws. You just identify what you have. So given an initial pressure of 12 atm, so that's going to be pressure 1, and an initial volume of 29 liters, so that's going to be volume 1. What would our pressure be if the volume decreased to 10 liters? Whoops, there we go. So that's going to be volume 2. So just thinking about this in your mind before you even solve it, if the volume is 29 liters initially, and then we are decreasing that volume to 10 liters, remembering our relationship, if the volume is decreasing, that means the pressure must be increasing. So our pressure better end up larger than 12 atm. We don't have to do any conversions because we're already in atm and liters. So we have 12 atm is our initial pressure, and we don't know our P2. Let's set it up. We have 12 atm. I'm going to put it in parentheses. That's going to be better. 12 atm, and that's going to be multiplied by our volume 1, which is 29 liters. And that's going to set up equal to, and we don't know our pressure 2. That's going to be X. And that's going to be multiplied by 10 liters. So if we multiply that out, we have 12 multiplied by 29. That's going to give us 348. 348 is going to be set equal to 10x, and then we simply just divide by 10. So divide by 10. This one is a little bit different from our other laws just because it's in multiplication form, but it's very straightforward. Divide by 2. What am I doing? Why am I dividing by 2? It's been a long morning. We are going to divide by 10 because we want the x by itself. So divide by 10. Divide by 10. 348 divided by 10 is going to give us 34.8. We're going to keep it to two significant figures, however. So we're going to go to 35. And we are measuring this because we're solving, remember, for pressure. So we're measuring this in atm. So our new pressure is going to be 35 atmospheres. Now, at the beginning, we said if the pressure or the volume is decreasing, that must mean the pressure is going to end up bigger than 12. And it did. It increased to 35 atmospheres because as you shrunk that volume, the pressure is going to increase because it is an indirect relationship. Okay, let's look down here. Nick had a container of oxygen gas with a volume of 450 milliliters. Right away, I know that that's going to be my V1, but I also know I need to convert it to liters. To convert it to liters, remember you just do 450 divided by 1,000. So that means our volume 1, if that is converted into liters, is going to just be 0.450 liters. So let's just do that right away. And a current pressure of 1.77 atm. So that's going to be our P1. P1. If Nick decreases the volume to 350 milliliters, so we're back to volume, that's going to be our volume 2. And again, it's in milliliters. So if we convert that into liters, this is going to be 0.350. 0.350 liters. And that's going to be our V2. What will be his new pressure? So we're solving for P2. So let's set up our equation. Our P1 is 1.77 atm. Multiply that by our V1, which we just shifted to liters, so it's 0.450 liters. That's going to equal X because we don't know our P2, multiplied by 0.350. So you have 1.77 multiplied by 0.450. That's going to give you 0.80, just round it up. That's going to be set equal to 0.350x. So we divide each side by 0.350. So you divide each side here because we want the x by itself, right? So we divide each side by 0.350, 0.350, just like that. So 0.8 divided by 0.350. My answer is going to be about 2.3. So x equals about 2.3. And what were we solving for? I'm going to round that to 3 sig figs, so 2.28. And we were solving for the new pressure, so that's going to be in atmospheres. So you can see here, again, if he decreases the volume, it's going to end up decreasing the pressure because the pressure decreased from you decrease the volume, it's going to increase the pressure because it's an inverse relationship. So it is going to increase the pressure from 1.77 to 2.28 because the volume decreases. That is Boyles Law, basic introduction. Relationship between pressure and volume, an indirect relationship. One increases, the other decreases. There we go, Boyles Law. Farewell.